Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look at using arrays for data deduplication and reporting. Modern computers have a great deal of memory in comparison to those computers which existed at the time when Windows was first created. PowerBasic is a 32-bit application. This means it gets to use up to 2 GB of memory in your computer. However, in PowerBasic you can also use one of the hash options to increase the amount of memory your application can use to approximately 3 GB. 3 GB is a great deal of memory, and you are unlikely to have an application which needs more than this. One of the advantages of doing things in memory, as opposed to reading it sequentially off disk, is that things will happen a great deal faster. One way of handling data in large amounts is to put it into an array. So what we're going to look at today is a bit of array handling. We're going to source some data, put it into an array, and then deduplicate the data within that array using a second array. So let's have a look at the code. When you're designing an application from scratch, it's always good to have a rough sketch of how the application is going to operate. And that's how we're going to approach the code today. We know that we're going to need some data, and this data is going to be loaded into a source array. We're then going to use the data within that source array to populate a second array, and the data within this second destination array is going to be deduplicated. So we will first declare a couple of arrays. These are our source and destination arrays. We are not at the moment setting the size of the array, merely the fact that the array is going to contain string data. Next, we will need to populate our source array. You may need to populate this from either a flat text file, from a SQL database, from somewhere else in the system, or some other method. So in this PB main function, we're going to call a function to prepare our data. And we're going to call this function prepareData. We're passing as a parameter to this new function the name of the array into which we want it to put the data, in this case the string source array. We won't create this function just yet, we'll continue sketching out how the application is going to work. So the function which is going to prepare the data will return either a true or a false. True if it has managed to populate the array, and false if it has not. This allows you to conditionally continue with your application. For this demonstration, we're going to populate the array with a small amount of data. So what I want to do next is to display the current contents of this source array. So we will create a new function to display the array on our log. And we'll call this new function displayArray. It also takes a single parameter, which is the name of the source array that we wish to display. Having displayed this initial data, we want to deduplicate it. So we'll create a new function whose task it will be to perform this function. This new function will be called deduplicateArrayByRow. My intention is to step through the source array one record at a time. Check to see if it's a duplicate, and then populate a second array, the destination array. So we're passing 3 parameters to this function. The name of the source array containing the data, the name of the destination array, and I'm going to tell it which row in the source array to begin at. So we'll need to declare a local variable for this start row. The reason I'm specifying a start row is that many datasets have as their first row a header line. This header line contains the names of all the columns within the data, and this is a line you'll want to keep in your destination array. If you have multiple header lines, then you can start your start row further down the dataset. So once we have deduplicated the array, by populating all the non-duplicates into the destination array, we can then attempt to redisplay the contents of the destination array. This will prove, to those of us who are watching, that the array has indeed been deduplicated. So this is the span of our entire application. We have sketched out what's going to be happening. We haven't actually written or populated these functions yet, but we now have a good idea of what we want our program to actually achieve. So since the first function was to prepare the data, let's go to that one first. So the purpose of this function is to prepare the data within the source array. We are passing in one parameter, which in this case is the name of the source array. I'm passing this by reference. All parameters are by default passed by reference, but I'm putting this in just for clarity. What Power Basic is actually doing for you is when it passes one of these parameters, it's not actually passing the entire content of the source array. Rather, it is passing a reference to where in memory this particular construct exists. This allows this prepare data function to populate the array of memory referenced by the parameter. This means any change we make to this array is reflected in the source location. So by doing this, it allows us to update the array. So when we pass back control to the calling function, all its data will have been updated because they are both in exactly the same location in memory. Since we have not yet prepared the size of the source array, we can issue a command to redimension the source array for any size we wish. In this case, I'm going to redimension it as a two-dimensional array, having 6 rows and 2 columns. We can then attempt to populate the array. You can populate the array quite easily by specifying the name of the array and within brackets the row and column that you wish to update. In this case, we want to update row number 1, column number 1 to have the value apple, and row number 1, column number 2 to be the value 4. To make your code more readable, it's sometimes useful to specify the column by using a constant. In this case, I'm using the type for the first column and the count for the second column. So anytime I refer using the percentage type constant, we know that's the type of the item we're talking about. So we will define both of these constants at the beginning of our application. As we have done in previous videos, we're using types of fruit and item counts. So the first column, column number 1, will contain the type of fruit. The second column, column number 2, will contain the count of those items. So we can now continue to populate the rest of the rows. So there we have 6 rows of data populated in the source array. Now this is a very small array with only a handful of rows. Normally you would expect your data array to contain a great deal more rows. But this is just for the purposes of demonstration. So we're returning the value true as the return of the function. If, for example, you were reading from a text file on disk, you could test for the presence of the file, and if the file does not exist or you are unable to open it, you can return false. So having populated the data in the prepared data function, we can now go back to pbmain to see what the next function to create is. Our next function is to display the array on the console. So this new function has the purpose of displaying a named array to the screen, and takes a single parameter, which is the pointer to the array. So as before, we're passing a single parameter by reference. This is a pointer to the array. You'll notice in here that the name of the array I've got in the brackets is strArray. It doesn't really matter the name of the variable you have in here. Since it's been passed by reference, you can call it something else entirely. It will still be pointing at the original location in memory. So we set some local variables up to allow us to step through this array, one row and one column at a time. So I'm putting a message out to the log to see what our output is. And then we're going to do a nested for next loop. When an array is dimensioned, if you do not specify otherwise, it will be dimensioned with a 0 element, a 0 row and a 0 column. In this case, we're not populating the 0 elements, so we're going to do our for next loop from 1 to the upper bounding of the array. This allows us to programmatically work out how big the array actually is. So we're using the ubound command, passing it 2 parameters. The first parameter, which is mandatory, is the name of the array. The second parameter is the dimension. If you do not specify the second parameter, it will assume the first dimension, the row. So this for next loop will go from 1 to 6, 6 being the upper bounding of this particular array. And we want to do all the columns as well. Now we know the code we've set up is to only have 2 columns, but we'll use the ubound command as well for this to work out what the number of columns actually is. So we're doing long C from 1 to the upper bounding of the array and the second dimension. PowerBasic supports arrays having n dimensions. So if you have a need for 3 or even 4 dimensional arrays, PowerBasic will allow you to do this. But today we're just using 2 dimensions. So we can now print the data within that out to our log. So since we're running through this for 2 columns, we'll accumulate the data into the strdata variable. So strdata will be equal to itself plus the value that's in the array for the row and the column we're actually dealing with. And then after we've displayed the last column in a row, we will print the data out to the log, and then we will empty out the data within the data variable to allow it to handle the next row. So this will display every record within a named array. So now that we've completed this function, let's go back to pbmain to see what's next to do. The next function is the one to do the deduplication. This one is a little more complex. This is taking in 3 parameters: the reference to the source array, the reference to the destination array, and a value which is the first row we want to start on. So as we have already dimensioned the source array, we'll need to dimension the destination array. Now at present we don't know how many records are going to end up in the destination array, because we're working on the assumption that there will be some duplicates in this source array. So there will certainly be no more records in the destination array than exist in the source array. So we will initially set up the destination array to be the same size as the source array. So we can do that quite easily by redimming the destination array and using the ubound command for the first and second dimensions. This will tell us how big the source array actually is, and will dimension the destination array to exactly the same size as a string array. Now that we've achieved that, we can now step through the source array 1 record at a time. Now in order to do this, we're going to need some local variables. I've set up one long R and a long C for the row and columns. I've also set up a count variable to count how many records we're actually putting into the destination array. And the last 2 variables are from the maximum number of rows and the maximum number of columns in the source array. We can populate these last 2 variables right away before we get into the for next loop. Again, using the ubound command. So the max rows contains the maximum number of rows in the source array, and max columns contains the maximum number of columns. Now what we need to do is a for next loop. The first element of this is to do long R, step through each of the rows, from the start row, which we passed in as one of our parameters, to the maximum number of rows. For this particular demonstration, we're working on the assumption that all the data in a row needs to be compared to see if there are any duplicates of all that data. You may in your own applications need to check just for a single column to see if that's duplicated elsewhere in the source array. So our task in this function is to determine whether the record we're currently pointing at in the source array exists in the destination array already. So to make our code simpler to read, I'm going to do this calculation to see whether it's already in the destination in a separate function. And we'll call that isAlreadyInDestination. And this new function will return a true or a false. It will return true if the value already exists in the destination, and false if it does not. Now we only want to add the data into the destination array if it does not exist in the source array. So we only need to test to see, is the value coming back from this function false? And if it is, we'll want to put the data into the destination array. We'll create this function shortly. But for the moment, we'll push on with this function. We set up a variable called longCount. This is a pointer to the next available slot in the destination array. At the moment, longCount has a value of 0. So the first thing to do is to increment that value. So longCount will now be pointing to the first record. Now we can do a nested for next loop, from the first column to the maximum number of columns, and we're making the element within the destination array for longCount long_C equal to the value in the source array. So we're populating the destination with the content within the source. And then we will go into the next record in the source array and do the same again. Once we reach the last row in the source array, the destination array will have been fully populated. And longCount will be pointing towards the last entry to be put into the destination array. Now, assuming there are actually some duplicates that have been detected in the source array, the content in the destination array will be less than the source array. So we can then redimension the destination array just to contain the rows we actually need. And again, this is easy to do using the redim preserve command. Redim followed by the word preserve means we're going to redimension the array, but we're going to preserve the data that's currently in it. We're setting the values to be longCount and the maximum number of columns. LongCount will be the last written record to the destination array. Everything after that in the destination array will be empty. So this will effectively throw away all the empty records and leave us with a destination array of a fixed size, fully populated. We can then return the value true. So we have referenced a new function isAlreadyInDestination within this function we're in at the moment. So we'll have to create that new function as well. So this new function will take 3 parameters. The first being the row. This is the row within the source array. The second 2 parameters will be the references for the source array and the destination array. And the purpose of this function is to return a true or false to say whether the row referenced exists in the destination array or not. Again, we're going to need some local variables to allow us to do this. We're using the minimum column and max column again to work out what the boundings of the arrays are. So I'm using lbound to determine the lowest element of the second dimension, and max column to be the upper bounding of the same dimension. And I can determine the maximum number of rows in the destination array by using ubound on the first dimension. So now that we have determined the boundaries of our array, we can now step through entries in the destination array using a for next loop. So for each item in this destination array, I'm going to be assuming that we have found what we're looking for. The reason for doing it this way is, if we assume that we have found the entry, if we do not find the entry, then we can return false. So we're going to need another nested for next loop here. As well as looking through each row, we have to compare each element of the array, each column. So within this nested for next loop, we can then test the element of the destination array against the element in the source array. So if the value does not match, it means we don't have to test any of the other columns. We can then skip on to the next row in the destination. We can do this quite easily. We'll just mark long found to be false, and we will use an exit for command. This will allow us to skip out of the for next loop on the columns and go to the next iteration of rows. However, if we get through to the very last column and we still haven't found any differences, then we have obviously found a record in the destination array which matches every column in the source array. In other words, this record already exists in the destination array. So we can test long found. If it is true, then we have definitely found a match, so there is no point in going any further. We don't have to test any of the other records within the destination array. We can return function equals true. So the record does exist in the destination array. If we get to the very last record in the destination array and we still haven't found any matches, then the value we return to the calling function is false. So now that we've created this function to determine whether the record exists in the destination array, we can now go back to the calling routine. There are no new functions within this calling routine to be created, so let's go back to pbmain. After the call to deduplicate the array by row, our next task is to, again, run the display array function, but this time using the destination array. Now we've already created the display array function, so we don't have to do any more work on that. So it looks as though we've completed all the code in our application. So let's try to compile it to ensure we haven't missed anything. And it compiles quite cleanly. So if we try running our application now, and let's see what it does. Well, we have a message at the top of the screen to say that the data has been prepared. So our source array has been populated with some data. We have then outputted that data to the console. So our function to display this source array is displaying the records on the screen. And we can see from this that there are a couple of duplicates in this source data. The apple and the watermelon are duplicated. So the deduplicate array by row function is run next. And we can see it's giving us a message to say the array has been deduplicated. And we were again calling the display array function, this time with the destination array. And in that we are getting just 4 entries. Only 1 entry for the apple and only 1 entry for the watermelon. So it certainly appears as though our deduplication routine is actually functional. So let's change one of the data items in our source to see if this will change. If we go to the prepared data, we can see there are indeed 2 values with apple, and they both have the value 4. If we change one of them to the value 3 and then run our application again, we will see that the source data is showing apple 3 and apple 4, and the output data has an apple 3 and an apple 4. So it has correctly picked up the fact that it now has 2 versions of apple. They are not the same, therefore they do not require deduplication. Although we are running this application with only 6 lines of data, it would work just as well with 600,000. Hopefully you'll find these routines and this approach useful in your own applications, but that's it for today. Thank you for watching.